Welcome students. We are back with another lesson. In this lesson, we'll solve numerical on amplitude, intensity at any point on interference pattern. So let's take our first question. Two plane monochromatic waves propagating in the same direction with the amplitude A and 2A and differing in phase by pi by 3 superpose. Calculate the amplitude of the resultant wave. So in this question they have said you have a two plane monochromatic waves. Okay, plane means your spherical or which type of wavefront? It is a plane wavefront. Fine. So two plane monochromatic. Mono means one, chroma means color. So a light having one color. That means a light having a constant wavelength. So a plane wave having a constant wavelength. So your light is a plane wave having a constant wavelength propagating in the same direction with the amplitude A. So here the amplitude of the first wave is A and 2A. The amplitude of the second wave is 2A. Fine. Now the two waves has a phase difference of how much? Pi by 3. Fine. The two waves are having a phase difference of pi by 3. Fine. So look here. You have two waves. This is your first wave. Fine. This wave has an amplitude. See how much? 1. Okay, this amplitude has 1. Now, in the question, they have given your second wave. This purple wave is your second wave. This second wave has an amplitude, how much? 2. This second wave has an amplitude 2. Apart from this, the second wave has an extra phase difference. Phase difference of how much? Pi by 3. What does this mean? So let us consider your first wave. This wave has the maximum amplitude at what value of x? At pi by 2. Fine. But your second wave, this second wave has the maximum value of the amplitude at how much value? This value at pi by 6, the amplitude is 2. Fine. So can you see there is a phase difference between the first wave, your blue wave, and your second wave, your purple wave? And how much is the phase difference? Pi by 3. So when the two waves superimpose, if the two waves superimpose, you get a resultant wave. This is your red wave. And they have asked us to calculate the amplitude. Okay, the amplitude of the resultant wave. Fine. So in our last class, we have derived the equation for the amplitude. Okay, let's go back to our last class. Here, the expression of the amplitude is given as the resultant amplitude A is equal to square root of A1 square, the amplitude of the first wave, A2 square, the amplitude of the second wave, plus twice of A1, A2 cos phi, where phi is the phase difference. So using the same relation here, so your resultant amplitude, let me denote as AR, equals to square root of A1 square, the amplitude of first wave, plus the amplitude of second wave, plus twice of A1, A2 cos phi. Fine. Now let us substitute the values here. A1 is A, A2 is 2A, phi is pi by 3. Let us substitute these values. So after substituting the values, your AR equals to A square plus 4A square plus, if I substitute A here, it will be, sorry, if I substitute A1, it will be A. If I substitute A2, 2A. So 2A times A will be 2A square multiplied by 2. So it will be, the answer will be 4a square. Fine. And then your cos of phase difference pi by 3. Okay, now look here. A square plus 4a square equals to how much? 5a square. Similarly, your cos pi by 3 is how much? Cos of 60 degree is half. So this term will be 4a square times half. Fine. So your resultant amplitude I can write as square root of 5a square plus 4a square root. Okay. Fine. Now here I can cancel this 2 and 4. If I cancel this 2 and 4, then here I'll be left with 2. Fine. So this whole term becomes 2a square. And 2a square plus 5a square will be how much? It will be 7a square. So your resultant amplitude AR equals to root 7a square. Fine. Now since this is a square term, I can write this one out of this square root. So if I write this one out of the square root, then I have root 7a. So the amplitude of the resultant wave is root 7a. Fine. So root 7 value turns around to be somewhere 2.64. Okay, somewhere around 2.645. So can you see this? The red one is your resultant wave. This resultant wave has a maximum amplitude of how much? 2.646, which is approximately root 7. Fine. So this is how you'll find your amplitude. Fine. The amplitude of the resultant wave. Now let's move to our next question. Now in our next question, two sources of intensity I and 4I are used in an interference experiment. Find the intensity at the point where the waves from the two sources superimposes with a phase difference of 0, pi by 2 and pi. So in this question, they have given you the intensity of the lights coming from the two slits. The light coming from the slit S1 has the intensity I, and the light coming from the slit S2 will be 4I. That means 4 times of the first wave. Now they have asked us to calculate the resultant intensity when the phase difference is 0, phase difference is pi by 2, and the phase difference is pi. So in our last class, we have derived the expression for the intensity. Your intensity equals to the intensity of the light coming from the slit S1 plus the intensity of the light coming from your slit S2 plus twice of root over I1 plus root over I2 times cos phi, and phi is your phase difference. So the resultant intensity at any point where the phase difference phi is given as your resultant intensity IR equals to I1 plus I2 plus 2 root over I1 root over I2 cos phi. So as given in the question, your intensity I1 is I, the intensity I2 is 4I, therefore let this equation be your equation 1, then equation 1 can be written as the resultant intensity I equals to, substitute the values. Here you will substitute I, here 4I, here substitute I, here substitute 4I. Fine. So this I plus I will be 5I, and here this 4, if I write this out of square root, then it will become 2, and 2 times 2 will be 4, plus here you have root over I, here you have root over I. So a square root of I times square root of I will give you I times your cos phi. Fine, so I can write the general expression of the intensity IRS 5I plus 4I cos phi. Okay, now what we'll do in this general expression, we'll substitute this phase difference phi. So let us substitute the first phase difference. So in your first case, your phase difference equals to 0. In that case, this expression, okay, this expression 2, equation 2 can be written as 5I plus 4I cos of 0. And you know how much is cos of 0? Cos of 0 is 1. Fine. So if I replace this simply 1, then I will have I plus 4I, 5I plus 4I, and 5I plus 4I equals to 9I. So the resultant intensity is how much? 9I. Fine. Now similarly, again let us substitute this phase difference pi by 2 here. So if I substitute the phase difference pi by 2, then I can write this expression as 5I 4I cos of pi by 2. And you know how much is cos pi by 2? Cos of 90. Cos of 90 is 0. Fine. So if it's 0, then 4I times 0 will be 0. Then this term will be cancelled. So what we are left with? Only 5I. Therefore, the resultant intensity will be how much? 5 times I. Okay. Now, in similar manner, you can find out the resultant intensity when the phase difference is phi. Okay. You can take this third one as your homework. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.